Okay, now that we're familiar with polar coordinates, let's do an example. Find all polar coordinates of the given point. So we're given a point in polar coordinates, and our job is to find all polar coordinates for this point. This is not the only way to locate this point with polar coordinates. There is an infinite amount of polar coordinates that we could use to locate this point. Okay, and I touched on that a little bit in the last video. Today we're going to actually write down all of those points. Okay, in your book, the book problems that I gave you, the instructions say to just find 4 different coordinate pairs. But the quiz that you're going to take wants you to find all of them and write it down as a set. So when you do those problems in your book, pretend that the instructions are like this: find all polar coordinates of the given point. That'll prepare you better for the quiz. Okay. Anyway, let's get to it. Where is this point? This is in polar form. I know because of the degrees. I know because this is r and theta. Remember, r is how far this point is from the origin, and theta is what angle from the positive x-axis this point is located. Okay, so let's just do a quick graph. There's our x and y axis. Is my pen running out of ink? Okay, I had to grab a new pen. Here we go. What were we doing again? Graphing this point. That's right. So we're at 135 degrees from 0, and 135 degrees is this way, 445 degrees past the y-axis there. So that is 135. That's our theta. And then r is 4. So we know that the distance from the origin there is 4 units, and there's our point. Okay, but that's not the only way to locate that point. We could locate that point by turning 135 degrees and then 360 more degrees after that, and we'd still be facing the same way, and then go 4 from the origin, and we'd end up at the same place. Okay, we touched on this last time, but I could go 135 plus any amount of 360s, right? Plus any amount of full turns, and all of those would be coterminal angles that are all facing that same way. And as long as I still have 4 as my radius, I'll end up at the same place. Okay, so I could do 135, I could do 135 plus 360, I could do 135 plus 720, plus every multiple of 360, positive and negative, right, would get me there. So how do we write that? Similar to how we did when we had multiple solutions for trig equations. Okay, so my radius is still 4 away from the origin, but then 135 is not the only angle that will get me there. I could also be 135 degrees plus any multiple of a full turn, right? 360 degrees times n. Okay, and as long as n is a positive or negative whole number, we're okay. And it's when you use the variable n, that's kind of implied that it's a positive or negative whole number. But if you want to be sure, you could always write this fancy notation that we've used all year that says that n belongs to the set of integers, meaning that n is a positive or negative whole number, right? Can't be like 1.3 or anything like that. It's got to be a whole number, right? Got to be an integer. Okay, so this is infinitely many coordinates that will locate the same point, right? However, it's not all. There's also infinitely more, and that would be when we use a radius of -4. Okay. Now, if you watched the last video, you know that how we deal with a negative radius is it's by going the opposite direction of where theta was orienting us, right? So if we were going 135 degrees, if we were oriented in 135 degrees and then had a radius of -4, we'd actually be 4 in this direction, right? So how can I use a radius of -4 and end up here? Well, if my theta faces me in this direction, and then I go have a radius of -4, I'd be facing this way. You know, I'd be facing this way, but then my radius would be sending me that way 4 units, which would land me right at that same point. Okay, hope that makes sense. So rather than going 135 degrees, I could go 135 plus 180, which would end up where? 135 plus 180, 315, right? So I could be 315 and I'd be facing this way, but then I'd go -4 units as a radius, and that would end me up right there. Okay, so 315 is not the only orientation that will give me this point with a radius of -4, but any coterminal angle, any multiple of 360 after that 315 degrees will orient me in that direction as well, and then the -4 radius will put me there. Okay, I know this is kind of a lot, but this is also this is the second half of the infinite amount of polar coordinates that will locate this point. Okay, I would love to stop there. However, the way that the Canvas lessons write this and the way that the Canvas quiz might write this, hint, is rather than doing this, they might have something like this, 135. And instead of adding 180 like we did, they'll write it out and then put the plus 360n. And then, I know you guys aren't going to like this. I didn't really like it either, but it's where we're at. They factor 180 out of these two terms here. So they do 135 plus, and they have their two terms with 180 degrees factored out to the right. So they pull 180 out of there, and they're left with 1. They pull 180 out of there, and they're left with 2n. And actually, they don't write it like that. They switch these around, so it's 2n plus 1 times 180. Okay, so this is starting to look like a mess. But I think the reason they do this is because this is all the odd numbers right here. Okay, this 2n plus 1, if you plug in every single positive or negative integer in for n, then this will generate all the odd numbers. So it's saying 135 degrees plus any odd number of half turns with the -4 radius will be this will give you all the same polar coordinates. Sorry, will give you the set of all polar coordinates that locate the same point. Okay, I know this seems like a lot. If you gave me this answer, stopped here and just gave me these two answers, I'd be thrilled. However, you might take a multiple choice quiz and this might be one of the answers, so you just have to know that these are the same thing. Okay. I know, guys, if that's confusing, come and ask me questions. That's what the Zoom office hours are for. Okay. We'll move on to a second example of doing the same thing. The only difference here is we're in polar form, but our theta is now in radians rather than degrees. Okay, so let's do this the same way. I'll just graph it really quickly. Pi over 6, that's about like that, about 30 degrees. It is 30 degrees. And then 8 units away from the center, it's out here. Okay, so here we are at pi over 6 radians, and then our radius is 8. So that's where our point is located. But just like before, that's not the only way to locate my point. I could also go pi over 6 plus any full rotation, right? Any whole number of full rotations in the positive direction or in the negative direction. So I could write this as pi over 6 plus 2 pi, that's a full rotation, but I could do any amount of those rotations, right? As long as this is a whole number, which since you use the letter n, it's implied that it's a whole number, okay, positive or negative. So it's implied that that's an integer. Okay, I gotta let my dog out. Hang on. Okay. Where were we? Yes, that's right. The other, so this is infinitely many coordinates that will all locate that point. We could also do the same thing with -8, right? A radius of -8. So if my theta orients me this direction, and then I have a -8 radius, I'll end up right there. So what's pi over 6 plus, what's a half a turn in radians again? Pi. So pi over 6 plus pi would be 7 pi over 6 plus 2 pi n. Now, I would love to leave it there because that just seems simple and easy to understand. However, in Canvas, they're actually going to write it like this, -8, and then they'll have pi over 6 plus 2n plus 1 pi. Just like before, how we had that 2n plus 1 times a half turn, we get that 2n plus 1 times a half turn. Okay, so if you want to just memorize it, which I know you guys love to just memorize things so you don't have to understand them very well, the way you do it is you just leave the radius alone and then add a 2 pi n to your initial radian value, your theta, and then you take that radius and you flip it to a negative, and then instead of 2 pi n, it's 2n plus 1 pi. And that'll get it. That'll get it every time. Okay. So I hope that makes sense, guys. I'm going to move on to the next example now. See you in the next video.